Good evening, students. Today we are going to learn about something. That means we are uh, dealing with current electricity chapter. That means in class 12 physics, the second chapter, that is second unit, is current electricity, and we have already done some of that part. Okay, of that part, some of that unit we have done already. So today we will start with a very interesting chapter, very interesting part of this unit, and that is the combination of resistance. Okay, and this thing we have already done in class 10. Okay, so that is we all know that combination of resistance, we have two kind of combination, that is series and parallel combination, and today we will deal with that only. A very interesting thing and very important topic in the respect of board exam also. And if you go for, if you want to give IIT JEE mains, advanced, NEET level, actually you can find some of the questions from that part also. Okay, so today we will deal with this thing, that is the combination of resistance. Okay, and we will take some of the NEET level or JEE level question, and we will try to solve that. Okay, so just everyone take out your copy and note it down. Okay, because this part is very much important and you have to note it down. Okay, so don't just sit idle. Okay, just note it down in your copy. So we will starting with combination of resistance. We have two kind of combination. One is series, another one is parallel. One is series, another one is parallel. We know that in case of series combination, the resistance, they are in this condition, because they are connected in a series. Okay, end-to-end connection. This is also called end-to-end connection. Okay. Okay, and parallel, that means they are connected, that means so they are connected like this. We all know that from class 10 only we have already dealt with this kind of question. That means we already done these things in class 10 only. That means what is series and what is parallel, we know these things. Okay, and we know that for finding out the equivalent resistance, this is equals to R1 plus R2 plus R3. Just the addition of the resistance. Okay, and this will be the case for parallel connection. This is the case for parallel connection. Today we will derive this thing, that how it is coming as series, how the resistance, it is equivalent resistance for series combination is the simple addition of the resistance, and in case of parallel resistance, it is the addition of simple, that is the addition of the reciprocal of resistance. Okay, so we will derive these things today. Okay, so let us do the derivation. first we will do series. The combination is like this. We will take for 3 resistance. Now the potential of the battery is V. That means potential of the battery is V, means this terminal is V and this terminal will be 0. Okay. Now what will happen? This voltage is V and this terminal will be 0. Okay. Now you will see, suppose this is R1, this is R2, this is R3. What will happen? This battery will flow a current. This battery will flow a current. Okay. And from class 10 only we have said that in case of series combination, the current in each resistance is same. So we know that, first point we know that I, that is current in each resistance is same. Current in each resistance is same. Now if we talk about the voltage in each resistor, voltage across each resistor, suppose the voltage across this resistor, first one, the voltage across the second resistor, around the second resistor, the voltage around the third resistor. Okay, the voltage is, let's say, for the first resistor, the voltage will be how much? I into R1. For the second resistor, again the voltage will be I into R2, because the current is same, that means I current is same, but the resistance are different. So the voltage, this one is V1, this one will be V2, this one will be V3. The voltage across the resistors, this one is R1, that means the voltage across the R1 resistance is, the voltage drop across the R1 resistance is I into R1. The voltage drop across the R2 resistance is I into R2. The voltage drop across the third resistor is I into R3. So I will see that the voltage across each resistor is not same. So voltage is not same. V across the each resistance is not same, and we can say the voltage, that means the voltage is the V is the voltage across the battery, and this voltage will go and it will cause some drop here, it will cause some voltage drop here in the R1 resistance, then it will cause some voltage drop across R2 resistance, and then it will cause some voltage drop at the R3 resistance, then it will come as 0. So actually this positive plate, it has the voltage V. Now the current will go and cause some voltage drop at R1 resistance, then cause some voltage drop at R2 resistance, then cause some voltage drop at R3 resistance, and then it will come as 0. So I can write V is equals to V1 plus V2 plus V3. That means the total drop of, that is the total voltage, is drop in the 3 resistance in the form of V1, V2, V3. That means resistance means it will drop the voltage. Resistance means it will give the resistance to pass the current. Okay, so obviously there will be some energy loss while passing through the current. So while passing the current through the conductor, the resistance will suffer, that means the conductor will suffer some resistance, that means the current will suffer some resistance. So this resistance will cause some voltage drop. Okay, so this V will cause some voltage drop at R1, then R2, then R3 and becomes 0. That means the V equal to V1 plus V2 plus V3. That I can write. Now, if this equivalent resistance, let's say the equivalent resistance will be like this. This is R eq and this is V, voltage drop. Then I can write, and this will be current I will flow through the equivalent resistance. Then I can write V equal to I into R eq equal to I into R1. Just we have done these things. I into R2, I into R3. Therefore, R eq equal to R1 to R3. So this is the formula. This way you have to derive this. Okay. That means the resistance across each resistance, the voltage drop will be different, and ultimately this the potential difference across the battery, that is the voltage, is drop in between the resistance. Okay, so this is the series combination, and this is the equivalent resistance for series combination. Okay, now we will go for parallel combination. Now we will go for parallel combination. Parallel combination. Parallel combination means R1, R2, R3. If the potential is V and 0, that means the positive plane it has potential V and negative plane it is 0. That means ultimately the potential difference is 0. So obviously this will be and this will be 0. Now we will see each resistance they are connected at the same potential difference. Each resistance they are connected across the same potential difference. This one will be also V and 0. This one will be also V and 0. This one will be also V and 0. So I can say V V across each resistance is same. Second point will be we will see that suppose the current is flowing as I, then obviously at each branch the current division will be different. Let's say it is I1, I2, I3. So I across each resistance is not same. And see this I, it is distributed in 3 terminals, in 3 branches. So this I is distributed in 3 branches, so I can say I equal to I1 plus I2 plus I3. Okay. Now we know that V equal to IR. Okay, so I can be written as V by R. So I1, that means the current across the R1 resistance. This is equals to V equal to R1. Now since the voltage across each resistance is same, so the voltage will be same. V by R2, V by R3. And what is I? I is V by R equivalent. Okay. So V equal I equal to V by R equivalent. That means I can say R equivalent equal to 1 by R1 plus 1 by R2 plus 1 by R3. This is the derivation for parallel combination. For parallel combination, the voltage across the each resistance is same, but the current across each resistance is different. But in case of series combination, the thing is just the opposite. That means in case of series combination, the current across each resistance is same, but the potential across the each resistance is different. Okay, so this is the formula. So this is the derivation. Okay, now one important thing I want to mention here. Suppose there is n resistance, n number of resistance connected in series, then the formula of Req equal to R1 plus R2. Now if they are of same values, same R, that is if the all resistance are of same resistance, same magnitude, R in it is all resistances are then you can write this NR. If n resistance is connected in series, then that means just R equivalent is NR. Okay. Now in this case n number of resistance connected in parallel, then what will happen? This is actually 1 by R eq, 1 by R1 plus 1 by R2 plus 1 by Rn. That means 1 by Req. Now if all the resistance having same magnitude, then it is 1 by R plus 1 by R, 1 by R, that is n into n by R. Therefore Req R by n, R by n. So for parallel connection, for n number of series are in parallel combination and having each resistance having same magnitude, then the equivalent resistance is R by n. And for series combination, if n number of resistance are in series combination and if each resistance having same magnitude, then the R equivalent resistance will be NR. I think it is clear to everyone. Okay. Therefore, if I say the two resistance, each of 2 ohm the 2 ohm resistance, they are in parallel combination, then what will the R equivalent? R equivalent will be 2 by 2. That means 1 ohm. Equivalent resistance is 1 ohm. Okay. One important point you have to note here, that means in case of series, R equivalent is greater than the greatest resistance in the connection, and in case of parallel, R equivalent is less than the least resistance in the connection. That means in case of series combination, the equivalent resistance is greater than the greatest resistance in the connection. Let's say I am taking 3 resistance. It is 10 ohm, it is 5 ohm, it is 2 ohm. Then in these 3 resistance, which one is the greatest resistance? Obviously the 10 ohm is the greatest resistance in the 3 resistance. And what will be the equivalent resistance? It is 2 plus 5 plus 10. That means 17 ohm. That means in case of series combination, the R equivalent, that means R equivalent is 17 in this case, R equivalent is greater than the greatest resistance. R equivalent is greater than the greatest resistance. Now in case of parallel, it is said that R equivalent is less than the least resistance in the connection. Let's take the example. Again the 3 ohm, 5 ohm, 10 ohm. So R equivalent will be 1 by R equivalent will be 1 by 10 ohm plus 1 by 5 ohm plus 1 by 2 ohm. Now in this 3 combination, this 2, 5 and 10, which one is the least resistance? Obviously 2 is the least resistance, and we find that the R equivalent, that means that the R equivalent that will come, it will be less than the 2 ohm. We will see what is the LCM. Is 10 is 1 plus 2 plus 5. That means 1 by R equivalent is this much. So it will come as 8 by 10. That means 4 by 5. That means R equivalent will be 5 by 4. This is ohm, and it will come as, if I do the division, it will come as 1.25 ohm. Now see, the R equivalent it is coming as 1.25 ohm and the least resistance is 2 ohm. Okay, so the R equivalent is less than the least resistance. So R equivalent is less than the least resistance. Okay, so this is a two important point you have to take it in your mind. So this is the series and parallel combination. Let's take some of the examples. That is, let's take some of the questions. Some of the combinations we'll take. So this is the circuit, okay, and you have to find out the equivalent resistance of this circuit. Okay, so now if this type of terminal is given, that means it is nothing. That means actually it is the battery connection. Okay, V volt. Obviously, this battery will flow some current. Now here the current will get divided and again. So this is the flow of current in the circuit. Now look carefully. This current is flowing, that means these two resistors, that is 2 ohm and 4 ohm, are in series combination, and this total, this 2 and 4, it is in parallel with 3. That means it can be written like this. That means it can be drawn like this. There is 3 plus 4, how much? It will come as 6. There is series, that means this is 6. Now this 6 and 3, they are in parallel combination. Then what will happen? The R equivalent will be, that means 1 by R equivalent will be 1 by 6 plus 1 by 3. That means 6. 1 plus 2. That means 1 by 3. 3 by 6. That means 1 by 2. Therefore, R equivalent will be 2 ohm. So here actually I can write it as 2 ohm. Now this 2 and 4, it is again in series combination. You will see that this is series combination. So obviously 2 plus 4 will become 6 ohm. This is 2. Now this 6 and 8 again they are in parallel combination. So 1 by Req will be 1 by 8 plus 1 by 6, 24. 3, 4, 7 by 24. That means 1 by Req. Therefore, Req will be 24 by 7. This is the ohm. Okay. So this will come as 24 by 7 ohm. Now this 24 by 7 ohm and 2 ohm, they are in series combination. So this will come as R equivalent will be 24 by 7 plus 2 ohm. That means 7, 24 plus 14. How much? 38 by 7 ohm. So in this case, the R equivalent will be 38 by 7 ohm. This is the R equivalent resistance. Okay. So this way, that means they are in series combination. That means 6. The 6 and 3 will be in parallel combination. Then, if 6 and 3 are in parallel combination, then it will come as 2. Now see, one thing I want to say, if two resistors are in parallel combination, this is R1, this is R2, then we can directly write it as R equivalent equal to R1 into R2 by R1 plus R2. I think you all know this thing. That means if two resistors are in parallel combination, then directly we can write this one. Okay? So this will come as, this total equivalent resistance will come as 2. And 2 and 4 again are in series combination. Then 2 plus 4 is 6. The 6 are in parallel combination with 8. So it will come as 24 by 7. Then 24 by 7 and 2 are in series combination. Then it will come as 38 by 7. Okay? I think it is clear to everyone. Very easy thing. Let's do this one. So what is the equivalent resistance of this combination? See, first of all you can see these two are in parallel combination. So in this case we can write R equivalent will be 2 into 4 by 2 plus 4, that means 8 by 6, that means 4 by 3 ohm. So in place of this I can write it as as 4 by 3 ohm This 4 by 3 ohm and 8 ohm, they are in series combination. Okay, so here it will be R equivalent will be 8 plus 4 by 3 ohm. That means 24 plus 4 by 3. That means 28 by 3 ohm. So here actually you can write 28 by 3 ohm. Okay. Now see, these 6 ohm, 28 by 3 ohm and 6 ohm, they are in series combination. They are end-to-end connected. So R equivalent for this 3 resistance will be 6 plus 6 plus 28 by 3. That means 36 plus 8, 44 plus 20, 64 by 3. So this is the equivalent resistance for these 3 terminals or 3 resistance. So here I can write 64 by 3 ohm. Now this 64 by 3 ohm and 10 ohm, they are in parallel combination. Then in this case it will come as 10 into 64 by 3 into 10 plus 64 by 3. Come as 640 by 3 by 94 by 3. By 94 ohm. Now simplify it, just you can find the equivalent resistance. Okay, so this is the equivalent resistance, that is the for that circuit, that for that combination of resistance, the equivalent resistance will be 640 by 94 ohm. Okay, very easily. Just you have to remember what is the formula and just identify which one is parallel and which one is series combination. Okay, now we will move to some complex circuits. Okay, we will move to some complex circuits. Now in these circuits, that means some complex circuits we will take here, we directly cannot find which one is series and which one is parallel. We cannot see directly. Okay, we have to identify by certain methods. Okay, so I will describe that methods. You cannot directly find out that this one is series and this one is parallel. The circuits that we have taken, in those circuits you can directly find that yes, this one is the parallel circuits, the parallel resistance, they are connected in parallel, and these resistors are connected in series. Okay, we can directly find out those things. Okay, now this is the method that we will use to find out which one is series and which one is parallel. That is the potential method. Potential method. Many complex circuits can be easily solved through this potential method. Let's take a simple example. First question. This is R, this is also R, this is also R. actually resistance, they are in series combination. Now the twist is now find out the equivalent resistance. Okay. Now this line is actually the connecting wire. Simply we just put the connecting wires. These are the connecting wires. These are the conducting wire. Okay, and the resistance is this. Now find out which one is what is the equivalent resistance. Now initially, if we see these resistance are in series connection and some connecting wires are just added. What is the resistance? Actually, though it is looking like a series, it is actually the resistance are connected in parallel combination. The resistance are connected in parallel combination. Let's see how. Suppose, actually what I have said that if this type of terminals is given, then actually it is connected with the battery. This terminal is connected with the battery. Now the positive plate, let's say the positive plate have V voltage and the negative plate it is 0 voltage. So potential difference is V. Now what will happen if this is positive voltage? That means this one is positive V, that is V, and this one is 0. Now if there is no element is connected in the circuit, that means see in this path, there is no resistance is there, no capacitance is there, no inductor is there. Inductor we will study in the next chapter. Okay. So there is no resistance is connected, there is no capacitance it is connected, no capacitor, no resistor is connected. So obviously this is the actually the conducting wire. Now if the current flow in the conducting wire, there is no potential drop, because in case of conductor there is no, when the current is flowing through the conductor there is no resistance suffered, and obviously there is no energy loss. Ideally there is no energy loss. In ideal case there is no energy loss, but in practical case there is always a resistance. If though the current is flowing through the conductor, okay, it suffers some kind of resistance and there will be a energy loss. But ideally if the current is flowing through the conductor, then there is no potential drop or there is no potential loss, there is no energy loss. So if the terminal is, if this point is V, then there is no potential loss. That means this terminal will be also V. This terminal is 0. That means this is 0. So there is no potential loss, and this will be also 0. Okay. Now see, if this point is V and if this point is 0 voltage, this resistance is connected between V and 0. This resistance is connected between V and 0. So we will connect it as V and 0. This resistance is connected between V and 0. This resistance is connected between V and 0. We will connect it as V and 0. Between V and 0. This resistance is also connected between V and 0. So obviously this resistance also connected between V and 0. No matter, see, in this case the terminal is changed, but in case of resistance we don't need. That means that here actually it is V and 0, but in this resistance it is V and this is V and 0. That means terminal it is changed. So in case of resistance, there is no, actually we don't need whatever the terminal is. It is the magnitude is same. That means it is connected between V and 0. Okay. Now look carefully. These three are in parallel combination. It is actually a parallel combination. The equivalent resistance will be R by 3. So this is actually a by potential drop method. By potential method we can find out the equivalent resistance for this combination of resistance, and this is very important. Now let's take another example. Now find out the equivalent resistance of this circuit. Okay. Now this is actually, it says that this branch and this branch, they are not connected. They are actually, this terminal, this branch is, it passes upper side of this branch. Okay. So they are not connected. They are not connected. Okay. Now find out the equivalent resistance of this circuit, of this combination of resistors. So what we will do, again we will connect a battery in this here also. It is also voltage V and 0. So obviously this voltage, here also voltage V. Now this, again this branch, there is no circuit element is there. So obviously this terminal is also V. This is 0. So this terminal is also 0. Okay. Now this is V, this is 0. Okay. So now see, these two resistors, they are connected to V and 0, connected between V and 0. These two resistors also connected between V and 0, connected between V and 0. These two resistors also connected between V and 0, connected between V and 0. These two resistors also connected between V and 0, V and 0. R equivalent will be 2R by 4. That means R by 2 ohm. It is just simple like this. Okay. So this is the beauty of potential method. Okay. Just see in which branch there is no circuit element, there is no resistance, there is no capacitor, there is no inductor. Then there will be no energy loss or energy gain. Okay. In case of inductor, there will be energy gain. Okay. So obviously there is no energy loss, there is no energy gain. So therefore the potential will be same. So here if there is V potential, that means here also V potential. If here it is 0 potential, then that means here also 0 potential. So you have to find out the each resistance connected in between which potential. Okay. So this is the equivalent resistance. So in this way we can find out the equivalent resistance with the help of potential method. Now we will do two circuits in homework. The potential method of it. So number 1 will be find Req between A and B. Okay, do this circuit and second will be same thing, that means find so this thing you will do by your own, okay, and show me in the class, okay. Next, one important circuit diagram that already came with the board exam. We will do now find out the equivalent resistance of this kind of circuit, okay. So it already came in the exam, okay. So we will do it by potential meter. Again we will connect a battery here, V0, so this is V, this is 0. Now here actually it is V, here actually it is 0. Now see, this is connected, there is no circuit element in this branch. So obviously this is V. Again there is no circuit element in this branch, it is 0. Okay. This is, again this branch, it has no circuit element, this is 0. Sorry. This is V. There is no circuit element in this branch, this is 0. Okay. So every terminal we get every terminal, this is one terminal, this is two. So every terminal we will get, we have already get, let's say it is V, it is 0. This 2 ohm is connected in between V and 0. Again, this 1 ohm, it is connected between V and 0. Connected between V and 0. This 4 ohm connected between V and 0. This 12 ohm, it is also connected between V and 0. This 6 ohm also connected between V and 0. So all the resistance are connected in parallel combination. Okay, so all the resistance connected between the circuits in a parallel combination. Okay. So 1 by R equivalent will be 1 by 6 plus 1 by 1 plus 1 by 2 plus 1 by 4 plus 1 by 12. Solve it and we will get the result. So this way we will do the problem in by potential method. We will solve the circuits by potential method. Okay. Now we have reached at the end of this video, that is another method, another type of circuit we will see. Then we will move to the Wheatstone-Bridge principle. Okay, that is for infinite network. This topic, actually it is not so important for board exam. It is very much important for IIT JEE and NEET, that level. IIT JEE and NEET level, that level of exam. That in that exam, this type of question will come. So we will do one of this type. In this type of network, all resistors are given of same magnitude. Okay. Now, this is the infinite. That means it is infinitely long. Okay. It is infinite network. For infinite network, what will be the equivalent resistance for this infinite network? Okay. So there are some process, there are some steps that we will follow. Okay, and we will get the answer then. So steps are actually steps. First step is that we have to consider the equivalent resistance of this circuit be X ohm. So for infinitely long resistors, combination of resistors, the equivalent resistance is considered as X ohm. Okay. Second is find out the repeating unit. Find out the repeating unit. Which one are the repeating unit? You will see. This is one repeating unit. This is the repeating unit. This is the repeating unit. So this is the repeating unit. So these two resistors are repeating at every loop. At every loop, these two resistors are repeating. That means this is the repeating unit. 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 Okay. So third step is that leaving one repeating unit consider the other part of the circuit and take valent equivalent resistance E x ohm. So leaving one repeating unit, consider the other part of the circuit and take the equivalent resistance x ohm. Now see, look it very carefully, make your mind clear, okay, and focus. If total resistance, if total equivalent resistance of this circuit is x, now it is infinitely long. We don't know how much resistance are connected. Okay. Now if I omit one resistance, then others are also actually it is repeating. It is continuously long. Okay, it is continuously long. So other part of this circuit also, the equivalent resistance will be x only, as it is infinitely long. Okay. So we will follow these steps. What are the steps that we will follow? So this is the repeating unit. And other part of the element, it is equivalent resistance is x ohm. So we have considered the total equivalent resistance of the circuit is x. Now as it is repeating, we have leave one repeating unit and take all the other resistance, and equivalent resistance is x. So this become very much simple. This R and X are in parallel combination and this is series. So R equivalent means, again for this unit also the equivalent resistance is x. For this circuit also the equivalent resistance is x, because it is infinitely long. So I can write x equal to R plus Rx by R plus x. Okay. So as it is infinitely long, you can take this. That means cross multiplication, that is Rx plus x square R square plus twice Rx, ultimately x square minus Rx minus R square equal to 2. Okay, so apply, so this is the quadratic equation. So apply Sridharajarya formula. It will come as, what is Sridharajarya formula? Minus b plus minus root over b square minus 4ac by 2a. So this is the Sridharajarya formula. Now here b is actually minus r. Minus and this minus formula minus will become plus. That means r plus minus. B is r, that is b square is r square minus 4. A is actually 1. C means minus r square. So minus r square and this r minus formula minus become plus r square. 2a is 1. So ultimately come as plus minus r root 5 by 2. So it will come as, if r will become common, 1 by plus minus root 5 by 2. Now we will see. So x it comes as 2 values, that means 1 plus root 5 by 2 into r, and second one is 1 minus root 5 by 2 into r. Now in this case you will see the value will come as negative. Root 5, the value of root 5 is greater than 1, so this will come as negative. So I cannot take this value because resistance cannot be negative. So the equivalent resistance of this circuit is 1 plus root over 5 by 2 into R. This is the value, this is the answer. So for infinite network we have to take this. So just recap, it means first of all we have to consider the equivalent resistance for the infinite network is X. Okay. Now find out the repeating unit. In this case the repeating unit is this. Okay. So leaving one repeating unit, take all the circuit element and the equivalent resistance is again X. So this will be the equivalent resistance, the simplified resistance. Then this becomes very much simple, that means these two resistors are in parallel, then it is series. Again the equivalent resistance is X. For this also the equivalent resistance, for this circuit also the equivalent resistance is X because it is infinitely long. Okay, so X equal to this, so solving this equation we will get this value. Okay, so this is the infinite network. For infinite network this way we have to solve. Okay, now the next topic that we will discuss in the next video, that means the Wheatstone bridge principle. Okay, that is very much important.